Hi everyone, today we're doing lesson 2.5, solving problems involving rate of change. Just by looking at a graph, you can find all the maximum or minimum values. You can do this by knowing a positive slope and a negative slope adjacent to each other. There will be a maximum, minimum, or a kink point. A maximum point on the graph is shown like so on the left side of the graph, and a minimum point is in the middle of the graph like so, and a kink is on the right side of the graph, in which a slope of the kink does not exist. When we are given a function and asked to find the maximum point, we find the adjacent increasing on the graph, then constant on the graph, then decreasing on the graph. The combination of all these three will give us a maximum point. When we are asked to find the minimum point, we find the adjacent decreasing on the graph, constant, then increasing. The combination of those three will give us the minimum point. Now let's look at example number 1 from your learning resources. Marianne is riding a Ferris wheel. The height of the Ferris wheel is represented by the following equation. H of t equals to 5 cos, in bracket 4, times t minus 10 degrees plus 5. At t equals to 55, will he be closest to the ground? So basically what the question is asking, at t equals to 55, is there going to be a minimum point? So when we're asked to find the minimum point, we know we need the combination of the slope decreasing, constant, then increasing. What we need to check is at point 54 to 55 seconds, is the slope decreasing. Then at time 55 to 56 seconds, is the slope increasing? If so, then we will have a minimum point. So let's first figure out the first part. At 54 to 55 is the slope decreasing. We do the same as we've done before, in which h of t equals to h2 minus h1 divided by x2 minus x1. h2 would be h55 minus h54, then it will be over 55 minus 54. That will give us the final answer of negative 0.0122 meters per second. This is the value of the slope, and since it is a negative value, we know that this has a negative slope. So we have just proved that from time 54 to time 55 seconds, the slope is negative. Now let's look at from time 55 seconds to time 56 seconds. We do the same as the last question, in which h of t equals to h2 minus h1 over x2 minus x1. That will give us the final answer of 0.0122 meters per second. That would be the slope from when time is 55 to time is 56 seconds. We can see that it is a positive value, therefore we have a positive slope. So we can clearly see the pattern of decreasing, constant, and increasing. Thus, a minimum occurs at t equals to 55, so yes, he would be closest to the ground at time is equal to 55 seconds. So that's the end of this lecture. I wish you guys good luck on your Unit 2 test, and I'll see you guys in Unit